The second podcast on nomenclature will cover compounds that have polyatomic ions. Now, polyatomic ions are also included in many of these compounds, and the naming is slightly different with polyatomic ions. First of all, a polyatomic ion is a bonded, covalently bonded species, and then the whole species has a name. So the NO3- that you see there is called the nitrate ion. It's a nitrogen in the center, the blue, and then 3 oxygens bonded to it. And then NO2-, again nitrogen, 2 oxygens bonded. The whole thing has a -1 charge. And so these polyatomic ions kind of act as units. And so you treat them as a whole single ion, but they're made up of multiple atoms. Now you can change a polyatomic ion by adding a hydrogen to it. So we can take the carbonate ion there, add a hydrogen to it, the charge changes, and then the name changes. It becomes hydrogen carbonate, which we know as bicarbonate. Then the same with the phosphate, you can add hydrogens to it, you can add hydrogens to the sulfate ion and make additional polyatomic ions. There are so many polyatomic ions. You're going to be given a table of polyatomic ions, and those are the ones that you're going to use most often. So we're going to kind of select the most common ones. Now, what do you do with naming with polyatomic ions? You write each ion. Cation comes first, so that's the positively charged ion, the metal. Again, don't show the charges in the final formula. When you balance the charges out, the overall charge must equal 0. So again, just as with binary ionic compounds, you want the total charge to be 0. So if the metal ion is +2 and the polyatomic ion is -2, then you don't need to add any additional subscripts. You never, ever change the subscripts on the polyatomic ion. So if sulfate is SO4, that 4 has to stay on there. If you want 2 of those SO4s, you then put parentheses around the SO4 and stick a 2 down as a subscript there. And then again, like always, we use Roman numerals when we're dealing with the transition metal. So that rule still stays in effect here. So let's take a compound, sodium sulfate, and let's try writing the formula for it. So we would go to the periodic table, we would look up sodium. Sodium is Na with a +1 charge. We would look up sulfate on our polyatomic ion table. It's SO4 with a -2 charge. And so we would need then 2 of those +1 sodiums to balance the charge, to get the total charge to 0. So 2 +1 sodiums, and then the -2 sulfate, that gives us a 0 charge. So we need a 2 subscript then on the sodium. So the formula becomes Na2SO4. Now, let's take a second example, this one with a transition metal. Notice it's iron, Roman numeral 3, hydroxide. So from the Roman numeral 3, we know the charge on iron is +3. We would go to our polyatomic ion sheet and find hydroxide. Hydroxide is OH with a -1 charge. So right now the positive is greater, +3 on the iron. So we'll need a total of 3 of those -1 hydroxides to get the total charge to 0. So the +3 on the iron will have 3 hydroxides, each at -1. Add those 2 together, we should get a 0. So that means we need 3 of those OHs. Now, the OH acts as a unit, so when we write the formula, we must put the OH in parentheses and put the subscript down below, outside the parentheses. Now, let's try one more. Let's take ammonium carbonate. Now, ammonium is a little unusual because it's one of the few polyatomic ions that has a positive charge, so it acts as a metal in the compound. So we would go to the polyatomic ion sheet and look up both ammonium and carbonate. Ammonium is NH4 with a +1 charge. Carbonate is CO3 with a -2 charge. So right now our negative is greater than our positive, -2 charge on the CO3. So we're going to need 2 of those +1 NH4s, 2 of them total. So we can add that +2 up, add it to the -2 of the carbonate and get a 0 charge. Now again, ammonium is a polyatomic ion, so to have 2 of them we must put the ammonium in parentheses and put the subscript 2 outside. So NH4,2CO3 would be the formula for ammonium carbonate. Now, let's make sure that you actually understand this. So again, this is a learning check, multiple choice. So take the first one, aluminum nitrate, write the formula, see if you can find it, complete all 4 of them. So you might want to pause here, because the next slide then is going to be the solution to all of these. Okay, so hopefully you have completed all 4 of these correctly. And again, if you have any questions about these ever, you can ask in class. But let's at least take a look at the first one there, number 1, aluminum nitrate. The symbol for aluminum, Al, if you go to your periodic table, it has a +3 charge. On the polyatomic ion sheet, nitrate would be NO3 with a -1 charge. So it takes 3 of those -1 nitrates to balance the +3 charge on the aluminum. Nitrate is a polyatomic ion, so in order to have 3 of them, we must use the parentheses and then the subscript 3 outside. And again, you would do similarly 2, 3, and 4. So now, what happens when we name compounds with polyatomic ions? Well, you recognize these compounds because they usually have at least 3 elements. So if you see a compound that has 3 elements, chances are there's a polyatomic ion in there. And so you go to your polyatomic ion table and you attempt then to find parts of the compound. You may want to circle them when you do this initially, but you need to begin to recognize them, and with practice you will. So the first example there is NaNO3. Na is sodium. Notice the compound has 3 elements, so chances are there's a polyatomic ion in there. And indeed, NO3 is a very common polyatomic ion, and it goes by the name of nitrate. So that compound would very simply be sodium nitrate. Now the second one here, notice again, 3 elements in the compound. The K, of course, is potassium. SO4 is sulfate, so we would call that compound potassium sulfate. And then finally the last one, aluminum. Notice this one has 4 elements. That HCO3 there goes by 2 names actually, bicarbonate or hydrogen carbonate, and it doesn't really matter which one of those 2 you use. So this particular compound then would be aluminum bicarbonate or aluminum hydrogen carbonate. Now, just to make sure that you're doing it correctly, let's take this learning check and go through and attempt to answer number 1 and number 2 there. So you may want to pause here. Now this next slide then is again practice, and there are 6 of them. So you want to take these 6 and go through and write the names correctly. Now these are mixed, so some of these are binary ionic compounds, some of these are containing polyatomic ions, they contain transition metals. So again, you may want to pause and write the formulas for the 6 of these, or excuse me, write the names for the 6 of these. And then finally, the last practice, let's take these 6, these are the names for 6 compounds, and you need to attempt to write the formulas for the 6. Keep in mind Roman numerals when they're in there, that means the charge on the metal. If the ending of the compound is ATE or ITE, chances are it's a polyatomic ion, so you need that sheet. If the ending is IDE, then it's just simply that element typically from the periodic table. So again, practice these 6.